Hello students, today we start the new chapter, that is the circle, the chapter 10 of class 9th. Here the exercise 10.2, the question first, that is the two circle they having the congruent, the circles are the congruent. We want to prove the angle subtended by the chord, they are equal, right? So two congruent circle mean the radii are equal, they have the same radii, that's why they are congruent. If they are the equal chord, and that is the chord is also equal, AB is equal to BC, we can say that is BC. So to prove angle AOB equal to angle BO dash C, so we can use here D also because they are differentiate this, so that is AB equal to DC, that is the chord AB equal to DC. So look at the solution. So we use the triangle AOB and the triangle DO dash C. So OA equal to O dash D, OB equal to O dash C, and AB equal to DC, that is the given, and they are the radii which is also given, they are equal. So triangle AOB, that is congruent to triangle DO dash C by side. If they are congruent, so corresponding parts are equal, so it means angle AOB, that is equal to DO dash C by corresponding parts of congruent triangle. They are the corresponding parts of congruent triangle. So next question, that is opposite to the first one, reciprocal we can say that. Here the two angles, the angles subtended by the chords on the center are equal, and the two congruent circles. So again we use the AOB triangle and the triangle DO dash C. So here OA equal to O dash D, OB equal to O dash C, and AOB, that is equal to DO dash C, that is the radii, it's a radii, and that is given. So that is the given angle, that one is equal to angle DO dash C and AOB, that is given. So it means the triangle AOB, that is congruent to triangle DO dash C by side angle side. By criteria we can use side angle side, one side, second side, and that is the angle between these two sides. So by CPCT, AB equal to DC, corresponding parts of congruent triangle, that is the corresponding parts of congruent triangle, right? So in the exercise 10.3, there is the first question, draw the different pair of the circles, how many points there does the each pair have the common. If we draw the different circles, there is a no common point, there is no common point, no one is there common. Another we can draw like that, yeah, we can say that two circles are touch at a one point, they are touch at a one point, that is one point, one common point. And another one, they are intersect each other, that is there are the 2 points, they are common, there is 2 points. So then we come to the question number 3. In that question, in question number 3, if the two circles intersect at the 2 points, prove that their center lie on the perpendicular bisect of the common chord. Their center is lie the perpendicular bisect. There are the two circles, that is the circle 1, and that is the common chord, that is O, that is O dash. AB is the common chord, it's a point M. We have to prove, right? So we want to prove that, O dash, that is the center of the two circle, and AB is the common chord. So we want to prove that the perpendicular bisect. Perpendicular bisect means that angle OMA equal to O dash MA equal to 90 degree, and AM equal to MB. We want to prove that these two things. So look at here. So first we join this also. Now we use the triangle AOB and triangle AO dash B. AOB and AO dash B, that these are the two triangles. So by this you can OA equal to OB, because that is the radius, that is OA. We can use these two triangles, that is the triangle AO dash O and triangle BO dash O, these two triangles, right? That one and that one, these two triangles we can use. So here OA equal to OB, right? Because the radius is a radius of the same circle, that is the circle, because the circle are not congruent, that's why we can use that is the from one circle, that is the radius of same circle, that is the radius of same circle. Similarly, that is the radius of same circle, that is the radius of same circle. So O dash A equal to O dash B, that is also the radius. And another one that is O dash is common. O dash is common. It's a common. So in this way, this triangle AO dash O, that is congruent to triangle BO dash O by SSS. These are congruent. If these two triangles are congruent, so their corresponding parts are equal. So we can say that this angle, that one, angle 1 is equal to angle 2. We can use also this angle 1 is equal to angle 2, right? So angle 1 equal to angle 2 by CPCT. That angle, that one is equal to that is angle 2, right? Now we use the another two triangle for the congruence, that is AOM and triangle BOM. That is here angle 1 equal to angle 2, it's a proof above. That is proof above. That is proof above. These two triangles are, these two angles are equal. Then OM is common. OM is common. And OA and OB is radius. It's a radius. So triangle AOM, that is congruent to triangle, it's a congruent to triangle BOM by SAS. If these two triangles are congruent, so it means AM equal to MB by CPCT, and that is the angle 3 and that is angle 4. Angle 3 equal to angle 4 again by CPCT. But you find out that angle 3 plus angle 4 is equal to 180 because it's a linear pair. Angle 3 and angle 4, their sum is 180 because that is linear pair. But both are equal, so you can say that angle 3, 2 of angle 3 equal to 180. So angle 3 is 90. Angle 3 is 90, it means angle 3 is AMO. So OMA. So OMA equal to O dash MA, that is 90 degree. So we have to prove these two things, right? So come to the next. Now come to the exercise 10.4. Now the question is, there is a two circle, the radii 5 cm and 3 cm intersect at a 2 point. The distance between their center is 4 cm. Find the length of the common chord. So that is the one circle the radius is 3 centimeter and another circle those radius is 5 centimeter and distance between their center that is 4 centimeter. Now O dash is the distance between the center that is 4 centimeter, radius that is 5 centimeter, another radius is 3 centimeter. Now that is the triangle O dash A. The greater one 5 centimeter, the side is 5 centimeter, that is square of 5 equal to square of 4, 2 and 3 and 4. So you get 25 equal to 25. It means that is the Pythagoras theorem implement on that. By the Pythagoras theorem, the converse of Pythagoras is said that triangle is a right angle triangle. If this triangle is a right angle triangle, so it means AB is a common chord. So you can say that is the twice, so 2 OA equal to 2 into 3, you get 6 centimeters. So common chord is 6 centimeter, right? Hello students, so come to the next question, that's question number 2. If the two equal chords of the circle intersecting within the circle, prove that the segment of the one chord are equal to the corresponding segment of the other chord. So two chords are equal. Here is given AB is equal to CD. AB is equal to CD. To prove AP equal to PB and PC equal to PD. Right? AP equal to PD, we have to prove AP equal to PD and PC equal to PB. So come to the two triangles, that is PON and PON. So angle M and angle N is 90 degree. We construct these two triangles and we join O and P. Right? Here we use the construction OM is perpendicular to AB and ON is perpendicular to CD, right? And we join OP. So angle M and N is 90 degree. OP is common in both. OM equal to ON. We know that if the two chords are equal, so their distance from the center is also equal. If the two chords are equal, their difference from the center is also equal. So in this way two triangles are congruent. So it means PM equal to PN, right? So make it by simplicity, make it 1. We know that AB equal to CD, that is given, right? We half the AB upon 2 and CD upon 2. You get AM. When you half, that is the AM and that is DN. It's make it 3. When we added the 1 and 3, MP plus AM, M to P and M to A. So it's become AP, P to N and N to D. It's become PD, right? Then make it 4. Now the second and 4, 2 is subtracted. The equation number 2 is subtracted from the 4. So AP minus AB minus AP and CD minus PD. AB minus AP, you get PB. Similarly CD minus PD, you get CP. Right? In this way, we have to prove the segment of the corresponding chords are equal. So come to the next question, that is question number 5. 3 girls, Reshma, Salma and Mandeep, they are playing a game and standing on the circle of radius 5 centimeter. The Reshma throw a ball to Salma and Salma to Mandeep. That is the distance between Reshma to Salma, that is 6, and Salma to Mandeep, that is also 6 meter. Right? We want to find the distance between Reshma and Mandeep. Okay, so radius is 5. Now to find that Rn, the distance between Reshma and Mandeep. So first we use the one triangle, that is SPM. That is a triangle SPM. It's a radius is 5. So if we use OP is X, so its PS is become 5 minus X. So SP is used 5 minus X and SM is 6. So by the Pythagoras theorem, the 5 minus X, the square of 5 minus X plus MP square equal to square of 514 use, that is the square of 6 by the Pythagoras theorem. by using the formula a minus b whole square. It's a 25 plus x square minus 10x plus pm square equal to 36. So make it equation number 1. Now we use the another triangle, that is PMO. So PMO, that is MP square plus x square equal to 25 equal to square of 5. It's become at 25. So MP square equal to 25 minus x square. So this value is put in the equation number 1 here in the place of MP square. So you get x square is cancelled with x square, and 25 plus 25 you get 50. So it's converting another side. So minus 10x equal to minus 14. So x is equal to 1.5. Now we want to pm square. So it's a 25 minus 1.4 square. So 1.96. It's become a 1.96. So 25 minus 1.96 you get 23.04. So if we want to find the square root of 23.04, so you get that is 4.8. But we want to find R to M, that is the PM. It's a double. We know that it's a double. So twice of 4.8 is become 9.6. So it means the distance between Reshma and Mandeep, that is 9.6. Okay. So come to the next. Question, that is three boys, Ankur, Sayyed and David, they are sitting on the surface of the circle with some distance. The radius of the circle is 20 meter. If the distance there is the given, they are having equal distance, but we don't know about the distance, but they have equal distance. AS equal to SD and that is equal to AD. If they are equal, it means ASD is an equilateral triangle. It's an equilateral triangle. In an equilateral triangle, we know that if they are inscribed in the circle, so it divided, that is altitude is divided into the 2:1, that is 2:1. It means OS ratio OM equal to 2:1. So OS upon OM equal to 2/1. So we want to find their OM. We know that OS is 20, so OM is become 10, that is 10. So OM is 10 meters, that is 10 meter. So now we use, that is the 10 meter. So OMD, we use the triangle OMD by Pythagoras theorem. OD, the square of OD, that is equal to MD plus OM square. So OD, that is 20. So square of 20 is become 400. MD we want to find, and the square of OM, that is the 10, is become 100. Now we shifted this side, you get 300. So MD equal to 300. So MD square is equal to 300. So we want to find MD. So it's become under root of 300. So under root of 300 we can written as under root of 300. That is 10 root 3, because it's a 300 is written as 3 into 100. So square of 100 is 10 and under root 3. So that is the square root of 300, that is 10 root 3. So we know that AD is the double of MD. So AD equal to 2 into 10 under root 3. It's become a 20 root 3 meter. So in this way, the distance between Ankur, Sayyed and Sayyed to David and David to Ankur, that is 20 under root 3. So that's about your exercise 10.4. Thank you and have a nice day.